Hello, welcome back to Piers Rocks. We're having a snow day here today, so after being outside and shoveling large amounts of snow, I'm pleased to be sitting back in the warmth. And today I'm planning to take another look at this 2040 disk drive that I looked at in a previous episode. If you've not seen the previous part, I'll put a link down in the description so you can go and take a look. But spoiler, after large amounts of fumbling on my behalf, I discovered that it was basically fully functional, this disk drive. However, what I didn't do was fully service the two drive units within this disk drive, and they didn't sound particularly good, and I don't have any experience of working with these full height drive mechanisms. So today I'm going to take them out of the disk drive, see if I can give them a good oiling and servicing, and put them back in, see if they sound a bit better, and most importantly check that the disk drive is still functional. So I have the unit opened up. As a reminder, we have the two drive units, that's drive 0 here and drive 1 here. We have the mains transformer here and two large capacitors there. And then on this side, which is actually the lid of the unit, which opens outward, we have the logic board for this disk drive. We're going to be concentrating on this section today. These are two full height 5¼ inch drive mechanisms. There's a driver board or control board for both disk drives here. So we've got the heads from each unit coming in here, I think, and then the other connections coming in the back of this circuit board, and then the logic or I/O from the main logic board connected here, and the power rails for the driver board, control board come in here. So first of all, I'll disconnect and remove this drive mechanism and we'll take a closer look, and I'll hopefully clean it up and lubricate it. Then we'll reinstall it and we'll take the second drive unit out and take a look at that and hopefully clean that up and lubricate it as well. I think both drive units are attached from the underside of the disk drive. So the first thing I'll do is connect the connectors for drive 0, and then I'll flip the unit over and unscrew it. So that's the read-write head for this unit. That's the other circuitry for this drive unit. I'll just point out that these connectors have tiny little plastic hooks on them. There's one just here and there's another one just here, and they should seat when you push the cable back in into these holes in the circuit board. So you need to be a little bit careful when you're removing them and reinserting them that you don't snap those off. Frankly, I'm a pretty clumsy person and I haven't managed to snap them off yet, so I suspect other people will be alright too. Just remove that cable out of the way. We've got the status LED wire coming across, but that shouldn't get in our way. That is connected to the drive unit. So yeah, I think this is fully disconnected now, so we can just flip the drive unit over and unscrew it from the underside. I flip the unit over and drive 0 is now on this side, and I can see there are 4 screws here that I obviously need to remove this drive unit. I'm just looking at it though and thinking that when I unscrew these screws, the whole drive unit is going to fall into the lid and logic board, which is now underneath where the drive unit itself is, which is up here. So I think what I'm going to do is just find something to go in between the two. I've got some pieces of foam lying around, so I'm just going to put a piece of foam in here so that, yeah, this will fall off, but it won't like fall and hit and damage either the logic board or the drive unit itself. So I have here some offcuts of shadow foam, which I think I can use to good effect in this situation. So that should be directly underneath the drive unit. There's probably only maybe a centimetre, if that, between the drive unit and that foam. So I'm just going to move this over a little bit more, but I think that should be in a fairly good place now. In fact, I think I can feel the drive unit is touching the foam. So I'll now get this unscrewed. So there we go, the drive unit 0 removed. So I will get rid of the main chassis and we can focus on this drive unit. So I'm zoomed down now onto the first drive unit, and I'm not sure there's a huge amount to say about it. We've got the read-write head underneath this piece here, and it looks pretty clean. I cleaned it in the last video. This lifty piece, which clamps down and pushes the media of the disc against the read-write head once the disc is inserted. So you insert the disc, this whole unit comes down, and this then pushes against the other side of the magnetic media as the disc spins around. It needs to be lubricated slightly at this point, where this plastic sticky outy bit, very technical terms, move up and down the drive cage. What else do we have? We obviously have the main drive spindle is underneath here, and then this piece clamps on top and needs to rotate, so I'll put a drop of oil in here. We'll need to lubricate the rails. We've got these metal rails. In fact, I will tip it up so you can see a little better. There's a rail here and a rail here. Those are the two rails that the drive head carriage unit slides up and down. In fact, you might be able to make out there is some lubricant on there already. I put that on last time, so I'll just make sure that's evenly distributed this time around. What else do we have? We have the motor here. I'm assuming that this is the spindle motor. It's in a similar place to that on a half-height AUX mechanism, so there should be a drive belt that goes from here to the underside of this piece to drive the spindle around. I was going to say presumably the tachometer's under here, but I'm not entirely sure. I'm guessing these are actually the drive wires for the motor itself, this red and blue, and these yellow and green right at the bottom of the unit are actually going into the tachometer. Now the reason I say that is because yellow and green, possibly yellow and grey, I can't remember, are used for the tachometer on the AUX 1541 mechanism, and the red and the blue are used for the drive voltage for the motor. I don't plan to take this apart and find out unless I find something's wrong with this, and it shouldn't be. We've got the cable to the activity LED. I'm not sure if there's enough light for you to see that, but it runs in here and comes out of the front, the drive LED. On the rear of the unit, so I'm hoping that's focused, we have a small logic board. Now I'm assuming that this provides the same function as the small circuit board on the underside of the AUX half-height mechanism, which is specifically to ensure that the spindle motor on this unit drives the disk drive at the correct speed. I'm having a look to see if I can see a potentiometer that you can turn to adjust it, and I can't. I can see a transistor, a capacitor, a bunch of capacitor. I'm guessing those are actually diodes, I'm not sure. That's an IC. I mean, the overall size of this, the colours of wires, obviously we've got the red and the blue. To drive the motor, we've got the tachometer yellow and green, if I'm right, and those really are the tachometer signals coming into this board. So yeah, I'm pretty sure this is the board that controls the speed of the motor. I'm even more convinced of that while I'm talking, because these yellow and green wires are going through a set of 4 diodes, which is almost certainly arranged as a rectifier to rectify the AC tachometer signal, then go into this resistor here, and then I'm guessing go up into the IC. Can't quite make out where the traces go to, but I'm pretty confident that's the purpose of this particular board. As I say, I don't see any use. Oh no, I've just found the potentiometer. It's this beige piece, and there's a screw to turn the potentiometer. I'm not sure if I can actually do a speed test of this disk drive. I'm not sure if there is a speed test program available for the Commodore PET. I'm hoping there is, and I can do a speed test at some point. But I don't think I can run this on my Commodore 64 using my IEEE 488 adapter with the program I've got, because they both require cartridges and I don't have a way of plugging 2 cartridges in at once. I could fix that, but I haven't fixed it yet. On the underside, yeah, we have the spindle motor here, which goes through this belt here, and this belt seems like it has a reasonable amount of tension to me, not like that horrific 2031 I fixed a while ago and had to replace the belt on. I don't know if this takes the same size belt as the 1541 Alps mechanism. As we can see, this was the original 5¼ inch disk drive mechanism, I think, built by Shugart Associates. We've got a model number of 390 and we've got the serial number of this unit. This is the stepper motor here. Obviously directly underneath the drive carriage mechanism. So I'm just having a look at it, and it's not actually grimy under here. I sort of originally thought this was grime, but it's just, it looks like discoloration on the surface of the, or pits on top of the metal. I'm assuming this is a cast I'm assuming this is a cast enclosure here, and I'm guessing that's just, maybe that's how it came from the factory with that patina on it. But it's definitely mature, and I think aging pretty well. So really my attention needs to be applied to this area of the disk drive. I'm just wondering if I can get in to oil. I can oil here. I'm not convinced I can easily get in to oil the base of the spindle motor. I might be able to get my oil dispenser in there, but I will do a bit of oiling now. I don't want to put too much oil on the mechanism, because you may get oil, I may get oil thrown off as the motor mechanism spins around and ends up getting put on the disc. And that's a particular problem, obviously, if it goes onto the magnetic media. While it's likely to go on the other side of the magnetic media, I quite often use my discs as flippy discs, so I can turn them over and use the other side. And I don't really want oil on them, so I just put the lightest amount of oil on there. I'm using a very light sewing machine oil here. That's what I tend to use to oil disk drive components. I'm just having a look in here to see if this is grimy. Yeah, this is a little bit grimy in here. The best way of cleaning this, I think, would be with compressed air, but I don't really want to do that. I don't want to spray compressed air on this. It will get dust everywhere, but I will, I think, clean a bunch of the reachable stuff, maybe with some cloths and with some Windex, and hopefully make it a little bit cleaner. Don't think I can get in there. Haven't got much space to work with in here. As I say, I really don't want to take this drive mechanism apart. Can I get any oil into the underside of this? No. Well, that might be in the right place. Just give it a little squeeze. No, that was not in the right place. So the oil's gone in the wrong place now. So I'll wipe that bit of oil up. I don't mind a bit of oil being on the surface of the cast metal drive base, as long as it's not particularly liquid and isn't going to spray anywhere. Just on this cast metal, presumably steel, it's not going to have a detrimental effect. Right, to clean the unit, I'm going to use this Windoline, which I don't think is particularly aggressive. It has some vinegar in it. Yeah, it definitely smells vinegary. Now, I don't want to go bonkers with this. You can see I managed to spray Windoline on the unit already. I have to make sure I give the read-write head a good clean with alcohol afterwards. I don't really want to get this stuff on the rubber belt on the underside. I'm not going to clean the underside because it really didn't look like it needed any cleaning. I've tended to find, if you're looking for these full height Shugart mechanisms, it's much cheaper to get them as part of a Commodore double disk drive than it is to buy them on their own. Now that might be because the ones that were installed in the first PCs had additional driver circuitry associated with them. So Commodore, I believe, certainly with the 1541, used their own driver circuitry, I'm not sure whether they did for this. I'm assuming it's their circuitry that is sitting on top of the other drive one. But if you're looking for just the physical mechanism, I'm assuming it's the same Model 390. It's the same physical mechanism used in PCs as was used in these Commodore disk drives. So as of the time of recording this video, I'm seeing the double-sized Commodore disk drives going on eBay for between 150 and 200 pounds. I think the most recent one I got was an 8050 that looked in a bit quite tatty condition. It was a little bit less than that, but 150 200 pounds seems to be the going rate. When people are asking much more than 200 pounds, well, they're having a laugh. You know, they're trying it on. They're not going to get that money, in my view. I can't really get in there with my cloth. Yeah, still lots of filth here. Now I'm going to get down there particularly easily. I'll just stuff this in. I'm trying to avoid removing this. I mean, I could unscrew it here. Don't think those screws have ever been unscrewed. I'm not sure I particularly want to be the person to do it, given the drive mechanism is, or at least was, working well before I took it apart. So that's, I mean, you can see the cloth's coming away with, maybe you can't, a bunch of grime on it. It's not terrible for its age. There's a bit of cobwebs down here by the LED cable. Actually, I think I've actually got the worst of the grime off. I don't want to go into this mechanism where the head is too much. I'm going to leave that be. I don't want to give the front a bit of a clean. And there's actually the remains of a sticky label. I think I caused this mess by tearing the original label off. This, I think, said Drive 0 when I received the unit. So I shall find some sticky stuff remover or Goo Gone. I like Goo Gone. Smells of oranges. Claims to have real orange oil in it, and it does do a good job of getting sticky stuff off. It can leave, I mean, it can cause a reaction with the surface you're using it on, and obviously I'm using it on 45-year-old plastic here, so I do need to be a little bit careful. Right, with Goo Gone, you put just a little bit on the area like that. I've got a couple of drops, and then you just work it around with your finger, and I can already feel this is starting to separate this old label, and you can see it's just coming off with my fingernail, thumbnail. Thumb is not a finger, right? And then my hands smell deliciously orangey. You can just rub the rest of the label and the Goo Gone off. Do that one more time, make sure it really has gone. So there's quite a texture in the surface of this drive faceplate. So it sort of gets lost in there a little bit. And there's a little white dot here that I want to try and remove. I don't know if that's taking the white dot off, or if I'm actually taking the surface of the faceplate off. Certainly doesn't seem to have improved it very much. So we will go to the magical solution of a Sharpie. Now, if there's oil from the Goo Gone on here, or Windoline, then the Sharpie probably won't take. But another white dot there. Well, I can barely tell that's been Sharpied, and the white dot has gone. For lubrication, I just tend to use this multi-purpose grease. I'm not sure it's the best thing to use. It was supplied by Prusa for cleaning one of their printers, so particularly for lubricating the X-axis rails. So I reckon if it's good enough for my 3D printer, it's good enough for the rails on this disk drive. That's that one done. This one's a little bit more tricky to access. Yeah, it's as far forward as it goes there. Can't really get underneath much of this, but what I think I can do is start here and then slide down with the unit. Yeah, you can see what I'm doing. So I just sort of put the Q-tip on the rail where there's a gap, and then just slide the Q-tip and the rail down. I do find it interesting that there's a little, must be a little detent. I'm not quite sure where the detent is, if it's on one of the rails, the rail I can't see, or somewhere else in the mechanism. But that's presumably at track 1. That's the detent, and that's the full extent of the disk drive. I'm guessing that's track 35, because I believe with the earliest Commodore disk drive units they only had the ability to access 35 tracks on the disk. That's why the 1541 and all the later disk drives default to 35 tracks on a disk for stock formatting. But the later disk drives had the ability to access 40 or in some cases even 41 tracks. This one I don't think did. Anyway, it does a detent, and I think the detent's in the middle, so I wonder if that is to make sure it nicely falls into track 18. Now while I've been doing that, I've noticed just inside the plastic here there's a little bit of grot. So I'm going to use a Q-tip with a little bit of alcohol just to clean that up. Now I'm using alcohol here on a plastic part. May not be the most well-advised thing to do, but I'm not going to put a huge amount of alcohol on it, and it will evaporate and dry up very quickly. Right, now let's see if I can see. There should be on the underneath of this, there should be a little foam pad, which is the part of this that actually pushes the disc down onto the read-write head. I just want to have a quick look at that. Yeah, it looks pretty filthy actually. I don't know if it's possible to clean that, or whether the grime will be caked in, but I'll give it a little bit of a rub with a Q-tip with alcohol. I mean, I don't know how easy it would be to replace this bit of foam. The Q-tip is getting a little bit dirty, and a little bit of alcohol will be soaking into that foam. Let's just see if I can show it to you. So if I put the unit on its side and then lift that out, you can just see the white pad by the end of my thumb. Next thing to do, I shall clean that read-write head again. I cleaned it last time around, but I don't think you can clean your read-write heads too many times. Actually, I'm just going to clean around the outside because it looks quite dusty. And I remember saying last time that I wondered if there was more filth on the surrounding area than there was on the read-write head themselves. So there you can see it's come away very black from cleaning around the read-write head. I don't think that's anything to do with the cleanliness of the read-write head itself, but it means there's a whole bunch of grime just sitting on it, and I don't want that near the disk media if I can help it. I'll just run that round there as well. Yeah, that's a little bit cleaner. And finally gets to cleaning the read-write head. So just lift this up if you need to. Give it a backwards and forwards. Turn the Q-tip around. Yeah, there's basically nothing come away there at all. Now there's one other thing that I want to grease here. I talked about it earlier, which is the sticky outy bit of the lifty uppy bit. So I want to put just a little bit of grease on here. We go, a little bit of grease on a Q-tip. Just rub it on there. That should do. And then I'll just clean the rest of it. But let's check that I've greased the full length of travel. I have. So I think this drive unit is serviced to my satisfaction. One final thing I'll do, just for funsies, is test the coil resistance of the read-write head. I'm expecting to see similar values to that used in the Alps half-height mechanism. Here we do, I think we have 5 cables. I don't know for sure. This one, actually no, this one's blanked off, so we have 4 cables. I'll bring the multimeter in so you can see the values. Right, so that's our first pair. 26 ohms, 17 ohms, and we know this is a good read-write head because I tested it and validated it worked last time. 30 ohms, 26 ohms, 12 or 13 ohms, 17 ohms. So yeah, those are very similar values to the ones we get with the Alps half-height mechanism. So what I'll do now is I shall get out the other drive unit and we'll take a look at that one. Here I have the other drive mechanism, so drive 1. So same deal with this one. I'll give it a good clean, I'll grease some bits and bobs, I'll take the residue of a sticker off the front. I'll generally just make it look a little bit nicer. Yeah, looks pretty good. Let's have a look at it on camera. I can see some other bits and bobs on camera here. It looks like the plastic's actually bulged a little bit, so I'm not sure there's anything particularly I can do about that. There's a little white spot there. I shall put some Sharpie on. But it's cleaner. Now I will lubricate. Start off with my sewing machine oil. It just goes in here. And I mean, I'd love to get it under there into the spindle motor rotating bit, but that's going to be pretty tricky. I'll put a little drop in here. That's probably just going to drip all over my bench now. Let's just try rotating it by hand to get it in. There's a very substantial bit of metal, this. Right, I'm just going to use a Q-tip just to get the excess off. I didn't grease the rails of this unit last time I looked at the drive, so I am going to do that this time. First thing, I'm going to clean them a little bit because they're probably quite dusty. Not sure I'm really going to be able to clean the other one though. Yeah, you see a bunch of grime coming off on that Q-tip there. Push the head forward. I can at least clean the back of this one. Yeah, filthy. Go around the head while I'm cleaning. It is absolutely filthy. Clean the read-write head as well. That actually had a little bit of grime on it, so I'll just clean it again. And then I shall clean the little foamy pad. Certainly getting some stuff coming off. Not a great deal. Right, let's do some greasing. Or lubing. For American viewers, lube has some very dubious connotations in the UK. We prefer to say oil or grease something rather than to lube it. I'll leave the viewer to consider what Brits might think lube is used for. I'm reminded of days past watching Mythbusters with the kids. Wondering if you can grease a disk drive with lard. Plenty of lard. Sure you can do it. Whether it's a good idea or not, I don't know. But it'll make it smell of chips. That's fries to Americans. Right, and then the final bit to lube is underneath that sticky outy bit of the lifty uppy bit, which is just there. Of course, I should have cleaned it first. Let's give it a clean. Clean all my lube up, and then come back and re-lube it. Right, that's clean. That's dry. There we go. Lubed. So I think this drive unit is also ready to be reinstalled. Before I do that though, let's take a look at the control board that came off the top of this one. Thought we'd take a quick look at this control board for the drive units. As I thought, we can see at the bottom here it says copyright 1978 Commodore International, so this is a Commodore designed and produced part. As I said earlier, I believe the Shugart drive mechanisms were also used in other computers like the IBM PC, and had a Shugart produced driver board. I've given this a little bit of a light dusting to get rid of the worst of the grime on it, and I've cleaned the gold contacts on both sides with Q-tip and alcohol. I don't like the drive unit. I don't want to do too much to clean this, because with something this old, the chances that I break it if I spend too much time working at it are quite high. I mean, there could be, these solder joints are obviously 45 years old, and I could break those. I could break a component. I could knock something loose. I just don't think it's worth the trouble when everything seems to be working fine as it is. I don't know what FA005970 is meant to represent on this board. The date codes on the chips on this board are similar to the date code on the main logic board, as you'd expect, 1978, 1979. In fact, there's a 7711 part there, so 11th week of 1977. That is a 7805. We have a 7721. 7913. This one I'm not so sure about. This looks, I mean, this says 844. I'm guessing that's not a date code because it's not been reworked, it's not been reinstalled. I mean, nothing on this board has been reworked. We can see a little bit of flux residue from the through-hole components. There's a little bit of flux residue there. Some of the solder joints are looking a little bit dull, but all in all faring well for its age, I would say. So this is board 320815 Rev C, I think. I will now reassemble the disk drive and check that it all works. To test out this disk drive, I thought I would drive it via a PC, a Linux PC, using my IEEE 488 version of an XUM1541 USB adapter for the Linux PC. So the 2040 disk drive is plugged in, it's turned on, it booted successfully. You can see it down below me. I have it plugged in via an IEEE 488 cable to my XUM1541, and that's then plugged into this Linux PC that you can see the shell for in front of you. First of all, I will check that the PC can see the 2040 disk drive. So let's do a CBM control detect. Device 8, unknown, footprint, DNO at. So I don't know what to make of that. I would expect CBM, OpenCBM, to be able to detect a 2040 disk drive. Even with DOS1 running, I would expect it to detect it. But let's put a disk in. So this is one of the floppy disks that I formatted last time in this disk drive, and I'll put it in drive 0. and we'll check we can read it. Now, I don't know if I need to force OpenCBM to issue an initialize command on this disk drive. So first thing I'll do is I'll try and read the disk. If that doesn't work, I'll figure out how to send the initialize command for that drive unit. So first of all, I want to do a CBM control dir of device 8. Yeah, so we get a read error. So it looks like I need to do an initialization of this disk drive. I can't quite remember how to do that. I think it's command, CBM control command. Let's see if I get any help for that. No, I don't. Alright, well, let's try sending I0 to device 8. Okay, I think it wants 8 followed by I0. Don't know if I need to quote it. Not convinced it sent that. The status light is now solid on the disk drive. So I'm not at all convinced I did the right thing. Let's try that. That doesn't look like it worked either. Okay, that sounds like the right way to issue the command because the heads are banging and it's presumably reading the disk. Now, so we'll try the CBM control dir8 again. Read error. Well, that's a shame. Let's try a different disk. So this is the 2031 demo disk. So I need to issue the I0 command again. Okay, no status LED. Okay, so we're getting problems reading the disk. Let's try it again. Okay, let's try it in the other disk drive. Now I need to initialize drive unit 1. Now, I'm not entirely sure how to do a DIR of a 2-drive unit. Maybe I can just do that. Okay, interestingly, that hit the same error as the first drive unit, so perhaps it's not a drive unit problem, maybe it's a disk problem. Hello, Editing Piers here again. Just like the last 2040 video, I've decided to step in and rescue you from my inept fumblings with this 2040 disk drive. After the clip that you've just seen, I decided to bring out the big guns and test it with the Commodore PET, but most of my testing still made use of that 2031 demo disk. After some Googling, it appears that DOS1, which I'm pretty confident this disk drive has installed, and DOS2, there are some incompatibilities, meaning that disks written for DOS2, which the 2031 demo disk will have been, simply won't work properly in a DOS1 device like this 2040. So it's no wonder that I'm hitting some problems with OpenCBM trying to do a DIR of that disk, and it's no wonder I hit all sorts of problems subsequently trying to copy that disk to other disks in this 2040 drive unit. I'm going to call it here for the end of part 2 on this 2040 video, and in a future video I'm going to take a much closer look at getting this working with OpenCBM. I have the OpenCBM source code open on a screen behind the camera right now, and I've been looking through, and I'm suspicious that OpenCBM is not even aware of the ROM version that I've got installed on this disk drive, and therefore it may not properly support the 2040, and I'd like to change that. If that sounds interesting and you want to see more videos like this one, please do subscribe. Until next time, rock on.